Hello everyone and welcome to today's webinar, Introduction to Amazon Web Services.
We're going to briefly describe cloud computing. We're going to talk about some of the benefits of the cloud. We'll talk about how the cloud scales. We're going to review the various Amazon Web Services building blocks. We'll cover a couple of case studies and some common use cases. We'll cover security, economics, and support. We'll then go over a few next steps where you can move ahead if you find what you've heard today to be of interest. And then after that, we'll have some time for some questions and answers and some discussion. Along the way, as time permits, I'm also hoping to give you a couple of demos through the AWS Management Console. So let's cover this really important question. What is cloud computing? You've probably noticed that suddenly there is just a lot of buzz and a lot of hype, and there's just articles and notes and tweets everywhere about this new concept, the cloud, the cloud, the cloud. What is it brand new? Is it something that's been around for a while? What exactly is going on here? So to me, it's kind of a nice logical extension of a lot of things that have been going on in the industry for quite some time now. And what we'd like to do to get you to kind of understand the concept of the cloud, think of your electricity service. When you use an electrically powered device, you simply plug into the electrical grid, and you count on the fact that behind the scenes of that grid, you've got a team of experts managing the grid, and they're giving you power that's going to be at a cost that's lower, more reliable, and with greater efficiency than you could generate on your own. You also get your bill from your utility service once per month, and so you're using power on demand, and you're paying only for the power that you actually consume. So by analogy, cloud computing is also a utility service. You have access to technology resources that are managed by experts and available to you on demand. You access these services over the internet, and you have no upfront fees to pay for them. So the question is, how can your organization benefit from the cloud? Let's take a look at some of the principal benefits. Here are some of the primary attributes of the cloud. Okay, we're going to start out with the fact that you get truly elastic capacity. You're able to scale up and scale down as needed. You can add additional servers, storage, databases, consume additional bandwidth, and so forth, all on an as-needed basis. When you're doing this, you don't need to invest in your own data centers or servers or any of the other equipment that you would traditionally need. So you have no capital expenditure. Because it's utility-based, it's a pay-as-you-go based model. So you're going to be billed once per month for your actual usage, and you're going to pay only for what you actually use. And next, a very, very important attribute of the cloud, you get to focus your engineering resources on the things that your organization, your business, does best. So instead of doing the undifferentiated work that in the non-cloud case you and your competition would all be doing to get data centers and acquire servers and rack them and stack them and wire them and supply them with power and connectivity and so forth, that's just essentially table stakes to get you started. So with the cloud, you can say, I'm going to just count on the cloud to take care of all those things for me. I'm going to really focus on my own business, and I'm going to do the things that are unique to my own business that set me apart from the competition. Because you're not worrying about all that obtaining and setting up and operating all that infrastructure, you're able to also improve time to market and get your new business online, up and running more quickly. You can respond to changes in the market. You can respond to calls for new markets, for changes in the way you build your application, the way you set things up, and the way you essentially have your application running in different ways much more quickly. The cloud is elastic, and there's no capital expenditure. So let's go through this graph. This is a graph that we've been using for some time now, but it really captures the concept really, really well of what elasticity really means and how well pay-per-use can match the real world of running in an unpredictable environment. So we've got infrastructure costs rising on the vertical side, and we've got time increasing over to the right. So let's say we're going to put our new business online, and we're going to do our best to predict the demand for that new business. we do our homework, we do our math, we make some calculations, and we come up with this dashed line to predict what our costs or what our infrastructure use should be. In the traditional mode, if we were to go out and acquire hardware, we would acquire hardware in these very discrete steps. We'd make a fairly large-scale investment at each step as we stepped up, and we would be investing ahead of our predicted demand. So because it's going to always have some lead time before we could actually have that hardware available to us and ready to run, configured, and set up, ready to go, we're always going to have to be making these investments before the traffic, before the business is there. Just a traditional model. So we're investing ahead of demand, and we're investing only based on the prediction. So we put our new business online, and what happens? The red line represents what's actually going to happen, and as you can see, the actual demand doesn't always match up really well with our prediction. What are the different cases that we have? So in the first case, our actual demand is going to be lower than our prediction. And so if we had invested in traditional hardware, what does this mean? This means that we overinvested in that hardware. We have idle hardware, we have too many servers, and we're not getting the proper return on our investment because we have simply acquired too much hardware. On the other end of the spectrum, maybe what happens is that our actual demand far outstrips our predicted demand. With traditional hardware, this means that we're in a world of hurt. We simply do not have enough resources to properly serve our customers. The systems are overloaded, the systems are slow, we might not have enough storage, we might not have enough bandwidth, we might not have enough compute power. In any case, what that means is we have demand that we're unable to fill. So traditional hardware makes it very, very difficult to actually accommodate this unpredictable demand. When we move to the cloud-based world, when we have this ability to dial in resources on demand, you can see that this gold line represents the fact that we can adjust very, very quickly in order to respond to actual demand. So we don't need to put those predictions into place up front. We don't need to invest in demand that might or might not materialize. Instead, up front, what we do is we're going to put our development, our engineering time into building a scalable architecture, making sure that as the actual demand arrives, we're able to accommodate it by simply adding new servers, putting them behind the load balancer, putting in rules into the auto-scaling system to add and remove servers from the system as needed. So with the cloud, we're able to much more closely track actual demand, and we can build businesses that are going to be scalable and yet profitable at any business size. Let's talk about what scalable actually means. This is a graph that we've been showing for a couple of years, and it's a great illustration of what scale really means in practice. This is one of our earlier customers called Animoto. They have a video processing application that takes a set of pictures and some music and analyzes the pictures, analyzes the music, creates a music video for you. Back in 2008, they launched this as a Facebook application, and before they launched it, they were running on about 50 servers. They had some very interesting viral features in the application to make it so it was very, very easy once you create your own video to share that video with your friends, who then would naturally all want to actually create their own video as well. So they launched this application, and in the course of 3 days, they went from running on 50 servers to 5,000 servers, which we call instances in our vocabulary. They went from 50 up to 5,000, a factor of 100 scaling, in a matter of just 3 days. So this is what runaway success can look like in practice in today's world. The on-demand nature of the cloud is also something we should take a look at. This is another one of our customers. This one happens to be a Wall Street hedge fund. We are not allowed to disclose their name, but this is their CPU usage over the course of a week. They really have two different modes. During the trading day, they're running about 3,000 servers or instances, and so during the day, actually, they run about 300. At the end of the day, they scale up from 300 up to 3,000. They do their end-of-day processing, they do their risk calculations, and so forth. So they go up by a factor of 10 to do those calculations. Once those calculations are complete, they shut down all those extra servers, wait for the next start of the next trading day. You can see that they maintain about 300 servers running for essentially background or continuous processing. When they don't do any trading on the weekends, they have no need to ramp up from the 300 up to 3,000. So you see that over the weekend they're running at just 300. So this is an example of a predictable demand where they're able to dial up and then dial back down their resource consumption. The cloud's also going to enable you to innovate more quickly. So remember I talked about the undifferentiated things that you and your competition would have to do in the non-cloud case. The numbers that we've collected and the numbers that we've obtained both from internal use and from talking to our customers say that this undifferentiated heavy lifting, all the things that you and your competition need to do to simply get ready to run your business, generally comprises about 70% of your workload, leaving you just 30% of the time to actually create your business and do the unique things that set you apart from the competition and to actually innovate. The cloud model actually flips that proportion around and basically gets you to the point where about 30% of your time should be spent architecting and configuring your cloud assets, giving you 70% of the time to do what's unique to you and to your business, so you're able to focus on your business. So by moving to the cloud, we believe you can more than double the amount of time you're able to focus on your business and really reduce the amount of time you're going to be focusing on your IT resources. It also gives you the ability to be a lot more agile in a business sense. So every business has a lot of great ideas, and they'd like to be able to get those ideas online as quickly as possible. In the traditional world, this means you need to talk to your IT person, and sometimes you're going to find that IT is not able to respond quickly. We talk to our customers and often find that IT organizations can take anywhere from weeks to months, and believe it or not, sometimes even quarters, to get new businesses online within a large organization. They're simply not equipped to respond quickly to dramatic changes in resource requirements. By going to the cloud-based model, what our customers have found is that they become a lot more agile. They have great ideas, they can get the resources they need from the cloud, and they can put them online in a matter of hours rather than weeks, months, or quarters. So they go from great ideas to great ideas online and up and running far more quickly. They can do experiments, they can do tests, they can put things online for a little while and say, does this work? If it works, they can roll it out to new markets, to larger customer bases. If not, they can bring it back to the lab, they can shut down the cloud resources and continue to innovate. So they can run that innovation cycle much more quickly when they're using cloud-based resources. So people ask us all the time about the ability for the cloud to scale. Can it really handle the very, very large-sized businesses? So this is the level of capacity that we add to AWS. When Amazon.com was in its 5th year of operation, we had a certain amount of IT resources. We were doing $2.76 billion a year in business. So we had a certain amount of IT capacity to power that. Every day, we had enough additional capacity to Amazon Web Services to power that entire $2.76 billion company. So that's the degree of growth that we're currently undergoing with the Amazon Web Services. Another metric that I can share with you is we have a storage facility called Amazon S3, the Simple Storage Service. As of the end of the second quarter of this year, S3 holds 449 billion objects, and we process over 290,000 requests per second for those objects. On the customer side, you can see that we have a number of different brand name customers. We'll take a look at case studies from a few of these. We have a number of additional case studies available to you on our website if any of these particular customers look of interest to you. And if you want to find out about what any of the Virgin Atlantic or Netflix or Playfish or any of these customers here are doing with the Amazon Web Services. We also have a nice partner ecosystem, and these are some of our brand name partners. And again, we have more information on our website available if you want to find out about the different things that we're doing in conjunction with these partners. As an example, we just announced an expanded set of Oracle applications running on AWS just last night. We have a global reach with the Amazon Web Services, and let me give you a couple different indications of what that means. So when you start to store and process information in the cloud, you always get to choose a particular location that we call a region. We currently have 6 different regions located around the world. So when you choose to store or to process, you're always going to choose a particular region, and you're going to direct your requests to a particular region. So if you must keep your information within a particular country, if you must keep it outside of a particular country, you have full choice of where it's stored and where it's processed when you're using AWS. We have 3 separate locations in the U.S. We have both on the east and the west coast of the U.S. We have a brand new region that we just announced earlier this week that we call GovCloud, and this one is restricted to federal, state, and local government applications hosted in the cloud. It has a very specific feature called ITAR compliance, meaning that we have a restriction that only U.S. personnel, people that are either U.S. citizens or permanent residents, are allowed to operate that cloud for us, and we have a specific set of restrictions about the kind of applications, the kind of agencies that are allowed to be. And then we have a region in Europe, in Dublin, and then we have a pair of regions located in Asia Pacific, both Singapore and Tokyo. We have a content distribution network called CloudFront, and we currently have 19 locations for CloudFront located at various points of presence around the world. So now what I'd like to do is let's start zooming in a bit, and let's start taking a look at the individual building blocks that make up the Amazon Web Services. Now, each of these services is very comprehensive and very detailed. We probably won't get to address every last detail of every service in the time that we have available today. If you do have additional questions, please feel free to put those into the chat box, and also you can consult information on the website to learn even more about each of these different services. So at the bottom we have Amazon's global physical infrastructure. We just talked about the regions, the fact that we have 6 separate geographical regions located around the globe. Within those regions, we further subdivide them into a concept that we call AZs, or availability zones. Each of these availability zones is effectively a separate data center with individual power, cooling, network connectivity, and so forth. When we give architectural guidance for the use of AWS, we always recommend that you take the different servers that comprise your application and distribute them across the different availability zones in a region. This way, if there's any kind of failure that might affect a single availability zone, you've got processing available to you in the other availability zones. We also just talked about CloudFront and the different edge locations that are available within CloudFront. So the first level of service that we have is we have a compute service called Amazon EC2 Compute Cloud. EC2 gives you the ability to launch servers on demand that are virtual machines. So we take a large physical machine with a lot of CPU power, a lot of memory, a lot of network bandwidth, and then we use a technique called virtualization to subdivide that machine into logical, fully isolated virtual machines. EC2 gives you access to on-demand compute power, so you can quickly obtain and boot up new server instances in a matter of minutes. This means that you can very quickly scale your capacity up or down. We have 11 different server types, which we call instance types. These have varied amounts of CPU power, RAM, local disk storage, network bandwidth, and there's both 32 and 64-bit instance types available at a very, very wide range of power and price points. At the low end of that scale, we have something called a micro instance that's available to you at just 2 cents per hour. There are 3 different ways that you can actually pay for your compute power. The first model is called on-demand. So on-demand, you're paying the list prices for the actual instances, and when you're billed by the hour for the actual number of clock hours of servers that you are launching and running. If you have a predictable amount of demand, you can use something called a reserved instance or an RI. With the RI, what you do is you prepay upfront for either a 1-year or 3-year term, and once you've done that, you have the ability, when you run servers, you're going to be paying a lower hourly rate because you've prepaid, so your net hourly rate is going to be about 50% lower if you're going to be using that instance full time. If you're using it only part of the time, there's still a savings with reserved instances, and the amount of savings will depend on the proportion of the 100% that you use. Full details of that are available on the website. The third option is unique to the cloud and to AWS, and it's called spot pricing. With spot pricing, there is no fixed price for a compute hour at a particular location for an instance type. Instead, what you do is you prepare your machine image containing the application you'd like to run. You then make a bid for compute time, and your bid says you're willing to pay up to a certain price per hour to run your application at a certain location. Based on the supply of available compute time and the demand for that compute time from all the users of AWS and the other spot pricing requests, we will then establish a price for an hour of compute time, and all the applications that are willing to pay that price, we will launch them and run them, and we then reevaluate the market periodically based on changes in supply and demand. So spot pricing is been used very heavily by our customers, especially in the financial modeling and the various bioinformatics kinds of applications where they're able to get large amounts of compute power at the best possible price. When you launch EC2 servers, you have a choice of 4 different operating systems. You can run Windows, Linux, FreeBSD, or OpenSolaris. And this is an infrastructure as a service model, so that means that you're booting up a basic operating system, and you then have total flexibility to, on top of that operating system, install any additional tools, libraries, middleware, application platforms, and so forth that you'd like on that system. Once you've done that, we give you the ability to capture that customized operating system in what's called an AMI, an Amazon Machine Image. Once you have that AMI, you can then launch as many copies of it as you would like. As discussed before, you have the ability to launch servers across multiple availability zones in a particular region for reliability. And we have a service called CloudFront that monitors the status, the usage of the different EC2 instances, gives you things like network traffic in and out, disk traffic in and out, and CPU load. You can use CloudFront to do things like to monitor. You can also use it to drive automatic scaling activities. So what I'd like to do now, I'm going to flip over to the AWS Management Console in my browser. And so here's my browser. I have a number of tabs at the top. And I'm going to sit here on the EC2 tab. The menu right here is called the region menu. And you can see I can choose between any of the 5 publicly available regions here. I'm going to stay with the US East region. When I click on the Instances tab, it shows me the set of instances that I currently have running. I have 2 that are stopped and 2 that are in the running state. And if I want to launch a new instance, I simply click on the Launch Instance button. When I do that, I can choose between a set of pre-built AMIs in the Quick Start tab. If I happen to have built my own machine images, I can get those under the My AMIs tab. And I can also choose from a large selection of community AMIs built by members of our community and by our partner organizations. So let's say I just want to boot up, let's say, an Amazon Linux AMI. I can choose one from the list, let's say the 32-bit AMI. And I simply choose Select right there. On the second tab, I get to customize a few details of the launch. I'll wait for that to load. So the first thing I might want to choose is where do I want to launch it? I'm already inside the US East region, and I can choose any one of 4 separate availability zones in that region. If I leave that unspecified, then it will choose a suitable region for me. I can then choose how many instances I would like to launch, and for this demo, I'll simply choose 1. But if I wanted to, I could launch 2, 5, 10, 100 instances simultaneously with that option right there. And then I make my choice of what kind of instance I want to launch. In the step previously, I chose a 32-bit machine image, so the menu here actually shows me only the instance types that I can run a 32-bit image on. If I step back and say I want to run a 64-bit image instead, we'll go back and I'll show you that we have a different list entirely. So now I have a much larger list of available 64-bit machines. You can see that we go from at the low end, we have the micro, up to the largest machine is called a high memory quadruple extra large. Has 8 virtual cores and 68.4 gigabytes of memory. So you have quite a number of different choices. We'll stick with the micro. And from here, I can choose to simply launch instances, or I can request spot instances. We'll just go ahead and launch. In the next tab, I have control of some details. I can turn on additional monitoring. I can pass what's called user data into the instance, which we can pass, for example, configuration information if we want to do runtime configuration of the instance. And I'll leave all the other details unchanged. If I'd like, I can assign a name or a set of tags to the instance. So as I start to launch tens or hundreds of instances, I can use the tagging system to make sure I can tell them apart. Now for security, we also require you to use a key pair. I have a number of key pairs already created, so I'll simply select one from the menu. And we also have the concept of a security group that controls access to the instance. It controls the inbound. It's essentially an inbound firewall, and by default, the firewall doesn't allow any traffic. And with the security group, we can then enable particular kinds of traffic. I'll just choose my default security group. In the final step, the launch wizard confirms all my parameters, and I just go ahead and say launch. And then it's going to go ahead and start launching an instance for me. So this one is now in the pending state, as seen by the level, or by the yellow box right there. We'll just leave that there, and we'll come back in a few minutes, and we'll see that that has actually launched. Okay, so it's already up and running. If we click on it, we can see additional details. We can see that we have CloudWatch monitoring available for it, and we can see full details of that monitoring. Because we just launched it, we haven't accumulated any traffic or CPU utilization just yet. Okay, back to the presentation. So there you just saw me actually launch an EC2 instance, and you saw how quick that was to launch. That was probably about 20 seconds to get that micro instance up and running. So from compute, let's move along to storage. We have a couple different storage services for different types of data storage. We'll talk about 2 of those today. We'll talk about S3 and EBS, the Elastic Block Storage. So Elastic Block Storage is essentially a virtual hard drive, and you would use this just like you would use a hard drive on a physical server. You would use this as primary storage for a file system, a database, or anything that needs simply block-level storage. We can create these EBS volumes from the console, and when we create them, we can create them of any size from 1 gigabyte up to 1 terabyte. We create them. They're ready for us within a couple of seconds. We then attach them to an instance. We format it with a file system on top of that, specific to your operating system type. Once you have that ready to go, you can simply store information on there. Now, it's better than a hard drive because you can go to the console. You can right-click on a particular EBS volume, and you can initiate a snapshot backup. You can then use those snapshots for backup. You can use them for recovery if your application kind of goes awry and messes up your data, or if you need to make replicas of the data. Maybe you want to move data from test into production. And you can use it for any kind of recovery. If you need to scale up or scale down your amount of storage, you can use those EBS snapshots as well. So EBS is block storage, essentially virtual disk volumes in the cloud. The other kind of storage is object-based storage. We call the Simple Storage Service, or S3. And as I mentioned before, S3 currently has 449 billion objects stored. So this is a cloud-based, very, very durable storage model, designed to scale to high amounts of data, very, very high request rates, and to be highly durable, highly available. Also set up to be effectively your primary storage, accessible through a set of programming interfaces, and also through our console, a number of third-party tools for interactive management and backup. So let's go back to the console and see how that works. This time what I'll do is I'll select the S3 tab on my console. And when I do that, the console is going to list on the left side. It's going to list my containers or buckets. So I have a number of different buckets already in my account. I'm going to click on the one called JBar. And what I'm going to do, I'm going to click on the upload button, and I'm going to copy some information from my local machine up into the cloud. So I get my upload wizard. I'm going to click on the Add Files button here. And when I click on Add Files, I then get a file chooser, and I can go ahead and I can choose a file to upload. So let's see, what might I want to upload here? Okay, here's a good embarrassing picture. Upload a picture of myself. And what I can do, I can choose to set permissions on here, and I can choose to make that file public. So I'll go ahead and do that, and I'll say Start Upload. And then we go ahead and we've uploaded that file to Amazon S3. So because I made it public, the file has a URL available to it, and if we wanted to, we could go ahead and we could access that. So we can go ahead and select Properties in the console. So I uploaded one simple picture, but I don't have to pre-allocate storage. I can upload as much information as I would like to Amazon S3, and it will scale as large as you need to. So there's my upload, and there we go. That's the picture that I uploaded. That's me from 1962. So that was Amazon S3, and if we were to go ahead and say, well, that's an embarrassing picture, I don't want the whole world to see that, I could go ahead and I could remove permissions from that. I could save those permissions. So I've taken away the public ability to open or access that file. If I go back to my properties and access it a second time, I now get an access denied error showing that I no longer have access. So there's a very, very complete and very sophisticated access control mechanism with Amazon S3. Moving right along, multiple different network level services, including the virtual private cloud, the Elastic Load Balancer, and Amazon Route 53 for managing the domain name service associated with your domains. The virtual private cloud gives you the ability to create an isolated part of AWS, and then within that isolated section of AWS, you have full control of network addressing, and you can break that isolated cloud into multiple subnets. You can make some of those subnets private. You can connect those private subnets up to your corporate network across an encrypted VPN connection. And you can create both VPN gateways to create those VPN connections, and you can create internet gateways to connect out to the internet at large. So if you need much more fine-grained control of access, you can use the virtual private cloud. You even can control the IP address range of all the instances that are launched on your virtual private cloud. The picture here is from the management console, and you can see there's 4 separate predefined configurations for the virtual private cloud. This is most often used by our large-scale and our enterprise and our government customers, so they can make these walled-off sections of the cloud that they can have very, very detailed control of both the addressing and the accessibility of the instances and of the networks inside the virtual private cloud. We have multiple different database services, including the relational database service and the Amazon SimpleDB. The relational database service makes it easy to host, operate, and scale a relational database in the cloud. We currently support multiple versions of MySQL, and we also support Oracle Database 11G. When you're running these databases in the cloud, all of the common administrative tasks that are usually take up a lot of your time and your attention are automated, so that you simply launch a database in the cloud. We take care of backups, we take care of scaling, we take care of patches, and so forth. And again, less time on infrastructure for you, more time on application development. If we return to the console one more time, we have the RDS tab. And in the RDS tab, we can simply say Launch Database Instance. We can choose between MySQL and Oracle. If I choose MySQL, I can choose between currently 6 different versions of MySQL, both in the 5.1 and the 5.5 series. I can choose the type of machine I'd like to launch. I have 6 different instance sizes to launch on, ranging from a small all the way up to a quadruple extra large. I can add the ability to have multiple redundant copies of the database by simply choosing multiple AZ deployment. And I can opt to have the relational database service automatically update between minor versions for me. I can choose how much storage I'd like. I can assign a name for my database. I can assign a username and a password. And I can get my database up and going, again, just in a matter of a couple minutes. Specify a name, security groups. I can control when backups are taken and how long they're retained with the retention period and the backup windows. I confirm all the details of the launch. I say launch instance, and it generally takes just a couple of minutes to have a relational database up and running with the relational database service. So that's the relational database service. We have a number of services at the next level up. Time really kind of precludes me from going into a lot of detail on these. So let's kind of overview them fairly quickly. Elastic MapReduce for doing Hadoop-style large-scale parallel processing. Amazon DevPay and the flexible payment service for doing payment processing. Amazon CloudFront for doing content delivery. So if you have either static or dynamic content that's accessed by a worldwide audience, and you want to deliver that content to your audience with as low latency as possible, what you do is you use Amazon CloudFront. You create a CloudFront distribution. You point that distribution either at static content stored in Amazon S3, dynamic content on an EC2 instance, or coming from an Adobe Flash Media Server or another streaming source. And then CloudFront gives you a URL, which you then distribute that URL, and then access to the content through that URL will automatically go to the closest node in the CloudFront network. The Amazon Mechanical Turk gives you access to a worldwide workforce when you have human tasks that you need to organize and coordinate. We also have multiple different messaging services. We have the simple notification service for publish and subscribe style messaging on a topic basis. And we have the simple queue service when you want to build a large-scale application and you need a message queue to buffer work between the various stages and steps of that application. If your application needs to deliver large amounts of either bulk or transactional email, the simple email service, or SES, is the service you would use for doing that. Moving up another level, we have services such as identity and access management, where you can create individual user accounts inside the scope of your AWS account, and then you have very fine-grained control of permissions of those user accounts. We have multi-factor authentication, where you have to use a physical device with a 6-digit code on that device in order to log in to your account or to log in as a particular IAM user. We have Amazon CloudWatch, collects monitoring data, metric data from your instances, your volumes, your load balancers, and so forth. And then we have a couple of higher level tools. The first one's called the Elastic Beanstalk. Lets you build an application, upload the compiled application to AWS, and we'll then take care of creating all the infrastructure needed to run that application. The databases, the servers, the load balancers, the auto-scaling rules, managing version upgrades, managing backups, and so forth. The other service is called AWS CloudFormation. CloudFormation lets you create templates that describe your AWS infrastructure. These templates would specify the different instances that you need, the storage buckets, the message queues, the notifications, the security groups, and so forth. You create that entire template, and you can then realize all those different resources in the template by simply uploading the template through the console, hitting one button, and we'll automatically parse through the template, fill in any parameters that you've entered, and then create an entire application stack driven by that template. So it makes it very easy to design your architecture, encode that architecture in the template, and then create multiple copies of that architecture on a totally repeatable basis. So with Elastic Beanstalk, you simply upload your application. You can either launch a sample app in the launch screen, or you can upload your own application, and we'll take care of all the rest. We'll provision your AWS resources, we'll create the runtime environment for you, launch the application, and then handle all of the monitoring and scaling for you. And at the top level of this diagram, we have a number of different tools to make it easy for you to access AWS. If you're going in at the API level, and if you're going to write code to use these services, We have libraries and SDKs for a number of languages. We have PHP, Ruby, .NET, Java, Perl, and so forth. We have the Management Console, which I've shown you just a little bit of the Management Console in the demos that we have done so far. We have a very full-featured set of tools for Eclipse. If you're using Eclipse to build your applications, we just released the second major version of the AWS Toolkit for Eclipse. And then we also have a command line interface to a number of services. So if you have existing build tools, and if you want to extend those tools to automatically, let's say, create storage buckets or to launch instances, to launch databases, you can integrate your existing makefiles and build scripts and so forth with AWS using the command line interface, if you'd like. Okay, I think I'd like to pop back over to the Management Console for a little bit and show you that we did launch our database. So our database is just about booted up. That's the one that we launched just a few minutes ago. So after the database creates itself, the final step before it's available for you to use, it makes a complete snapshot backup. So we can look at our log file here. We can see that the first entry in the log was the database instance was created, and the second was that the database is backing itself up. I'll switch over to the monitoring tab here, and still waiting for some statistics to accumulate on the databases. Let's see if I select one of my other databases, they might have a little bit more in the way of statistics. There we go. So this is another one of my demo databases, and you can see that we have a certain amount of free storage, free memory. We have not that much in the way of write operations. We can click on that, and you can see I'm doing just about 1 write per second to that database. And we can see that in the graph. So all these different graphs and all these statistics that you see are actually collected and made available to you through CloudWatch, our monitoring service. CloudWatch also has its own tab on the console, and we can see all the different metrics that are collected. We can create alarms against any of those metrics. We can opt to get notifications from those metrics, and we can also use them to do things like driving auto-scaling operations. Now I'd like to talk to you about some of the ways that our customers are making use of AWS. These are the 4 principal areas that we see AWS being put to use by our customers. Many different types of consumer applications, high-performance computing with batch data processing and large-scale analytics, storage, backup, and disaster recovery, and then running enterprise and vertical applications. Here's a campaign that was run by an ad agency called Attic. They were asked by Toyota's Scion brand to create and deploy a reality series as part of a marketing campaign that they called Reinvent the Wheels. So when you put these campaigns online, they really don't have a good sense of just how popular they might be. And so they needed to be prepared for any level of viewership. So they set this up running on Amazon EC2. They put the static assets on Amazon S3, and they were able to stream video through Amazon CloudFront. They put this online, and in the space of 4 months, they attracted over 500,000 viewers, and in just 1 month, they were able to stream out over 5 terabytes of data to hundreds of thousands of viewers. So this is a great example of being able to scale, handle an event, and then at the end of the campaign, they can scale down and not have to have any lingering infrastructure costs. So going making a totally different kind of an application, NASA uses AWS for their mission data processing for a number of different current and future missions. One of the more interesting ones is that they process the data coming down from the Mars rovers. So in their old situation, they had a very, very limited amount of time to actually make decisions based on that data. It turns out there's simply a 2-hour window where they get the data from the rover. They do some image processing on that graphics and the telemetry data. They have a very short decision window once it's been processed to make decisions about where they'd like to send the rover. And then also within the same 2-hour window, they need to upload the decision, the results back to the rover and say, this is where you need to head for next. They built a horizontally scaling application running on EC2. They were able to scale up for this short time of this decision window, take all the data, scale up, do the processing, scale back down. And as a result, instead of what once took them 90 minutes to do data processing was reduced to just 15 minutes. And because of this, the amount of time they had each day to do the mission planning was greatly increased, and so they're able to do a much better job of doing better and higher quality science on Mars. This is what it looks like before and after. So in this 2-hour processing window, the pre-cloud model, the processing actually took most of the time. It had a little bit of time for planning, and then with the scalable processing that they're able to get from the cloud, they shrunk the processing time down. They expanded planning time from 15 minutes up to 105 minutes. And so, again, able to make much better decisions, look at a larger number of factors, make a much better plan. We always get questions about security, and what we've done is we've made a very large investment in AWS security. And in addition to investing in the security itself, we've done our best to publish information about the different security facts around AWS. We have pursued and achieved a large number of different certifications and validations, SAS 70, PCI DSS, ISO 27001. We have FSMA Low authority to operate for multiple government applications. We have white papers available both for security and for HIPAA. There's a third one not listed here called Risk and Compliance. In those white papers, you can read about our physical security and our data security. We have considerable detail in both of these white papers. If there's additional information that you need that's not covered, we're more than happy to connect you up to our security team. If you have particular questions, particular concerns, we're more than happy to answer those for you. If you'd like, you can visit the AWS Security Center to find the white paper, find out more information about all these different security features and facilities that we have. We get a number of questions about predicting costs. We do have an AWS calculator online. We also have an economics center and an economics white paper available to you. We also get questions regularly about the different support vehicles available. We have 4 different levels of support that are available to you at different cost points, ranging from bronze up through platinum. And you can see that there's a certain set of features available to you for each of these different support levels. At the highest level, if you're on the platinum level of support, you have access to an account manager and also to our team of solutions architects that can give you very high-level guidance on the best ways to build your AWS application. There's quite a few possible next steps for you. We have a Getting Started guide available to you online. You could use Elastic Beanstalk to submit a WAR file and watch it launch. You might want to check out the Security Center, the Economics Center. Or feel free to get in touch with me. My email address and my Twitter handle are on there. And with that, let's turn back to Reid. And in the remaining time that we have available, let's talk about any questions that you might have entered during the presentation.
Great, thanks, Jeff. I just want to let everyone know that we have a very similar presentation already online at slideshare.net/Amazon Web Services. You can go and find that there. There's just a couple little differences here due to the fact that we've already launched additional services such as the AWS GovCloud yesterday. 2 days ago, and so that's available. And then we also have a video that's similar to this recording that's online, and that's under the video and webinar section of our website, which you can easily find in the main AWS dropdown on our website. It just says videos and webinars, and you click on that, and you can watch all these videos there too. Just got a couple questions on that, so if you see that, that's what's going on. Jeff, we're actually going to start with a technical question that came through. It's a really good question from Mike. Mike has a specific use case he wants to talk about here, and the idea is they want to use the Elastic load balancing to externally point to Elastic IPs, which are obviously assigned to EC2 instances. And then they want to combine that with VPC for an internal network and an IPsec tunnel back to their data center. Can they support that type of configuration?
Wow, Mike, that's a great question that is probably something that we should handle in great detail offline. So let's see,
maybe the forum, Jeff.
Yeah, forum might be a good starting point for that, Mike. Yeah, you can definitely do all of these different things. You can create that IPsec tunnel to your virtual private cloud, and you can connect up from your corporate network up to your virtual private cloud. We are still working to support the Elastic Load Balancer and auto-scaling inside of the virtual private cloud, so you would need to run the load balancer outside the cloud, the virtual private cloud currently. Happy to discuss all those details if you want to follow up outside of our webinar.
Hey, Jeff, can you go back to the next steps to have your contact on that?
Sure.
There you go. Mike, hopefully that helps. So the next question we got is a couple people want to know how they can access instances from PuTTY.
Oh, okay. Really easy. Really, really easy. So let's go back to my console here. I glossed over a few steps when I was launching instances just in the interest of time. So I'm going to go back to my console. So when I'm getting started to use AWS, one of the things I need to do is I need to set up a key pair. So when I create the key pair, I simply need to press the Create Key Pair button. We'll create that key pair, and then the public part of that key pair will be downloaded, will be offered up to me for download. I then need to convert that key pair into the format that's used by PuTTY, using the PuTTYGen program. And once I've done that, I can load that up into PuTTY. And if I load up my PuTTY right here, you can see that I have it set up, and in my auth section, I simply have opened up my key pair. Once I do that and I say connect, and I'm now logged into my EC2 instance right here. So this is a small EC2 instance. You can actually see it's been running for 1,130 days. This is an almost archaic instance. I launched this well over 3 years ago. It's been up and running for over 3 years and doing great. So basically, you create your key pair in the console. You convert that to the PuTTY format. You configure it into PuTTY, and away you go.
Great. Thanks, Jeff. Jeff, here's a question from, I think it's Murik. Apologize if I did not pronounce your name correctly. He says, if there are many instances running based on one image, do they all have the same IP address and host name? How is this handled? And Jeff, I'm going to expand the question for you. Can you talk about some best practices when managing many instances of similar configuration?
Okay. All right. So what happens when you launch multiple instances from the same machine image is that each of them is assigned a separate IP address and a separate host name. So I'm going back to my Instances tab in my console. I'm just going to click on one of these. And then when I select a particular instance, what we can do is we can see that each of the instances has its own public DNS name. So this one is ec2-174-129-190-3.compute-1.amazonaws.com. So that's the public DNS name of that instance. It's also assigned an internal private IP address. So each of the individual instances will get its own name and its own IP address. And then you asked about what do you do when you start to have many instances. And what you want to do is you want to come up with some models or schemes for tagging your instances. So let's see, let me click on one of mine right here. We have a tagging feature that is relatively new, less than a year old. So what you can do is there's a tag called name, and I could call this one, let's say this I launched today, right? So this was demo Thursday. I can put a name tag on each one of those. So that's the first level of control. So I'd want to assign my machine's unique names as I launch them. But I could also go into the tagging tab of the console, and I can assign tags as I'd like. So maybe I want to have another tag called use. Maybe it's called staging server. And maybe I have another one called mode. I don't know, operational. So you can actually put up to 10 tags per instance. You can see those through the console. And if we'd like, we can configure the console. We can say show column. And if we show column, that tag then becomes available in the console. So I have the use column now here visible, and I can sort and I can filter by that tag. So if I only want to find things that are tagged as staging server, I could do it just like that with the apply filter. So critical to being able to stay organized as you launch tens, hundreds, thousands of servers is to think of a tagging model up front and then to just rigorously apply those tags as you start to launch instances. Great question.
Okay, thanks, Jeff. The next question we have is around using S3 to back up databases. Specifically, is S3 used only for storage files, or can we back up databases as well? Maybe you could talk about snapshots. Probably our last question, Jeff.
Okay, so S3 could definitely be used for database backup. You can store individual objects in S3 that can be anywhere from 1 byte up to 5 terabytes in size. So that should handle fairly large databases. What you would do, there's a couple different ways that you could do it. If you already have an application that can generate, let's say, a database dump or a tar file, you can use any number of command line tools to move that from your instance up to S3, or even from your local site up to S3. It doesn't make any difference S3 where the data is coming from. If you're running, and let's say so that's the kind of the S3 model from an existing database. You would then back up database dumps to S3. If you're using one of our own services, let's say you're using the relational database service, and again, I'll go back to the console. So if I'm using the relational database service, I have the ability to do snapshot backups of any of my database instances. So I'll go back to the database instances list. So I have my production database right here. If I want to do a backup, I can right-click on that, and I can say take snapshot. I'm going to call the snapshot, we're just going to call it Thursday. So when I say take snapshot, I'll go to the snapshot tab, and it shows that it's in the process of creating that snapshot. And in these demos, I've created snapshots of a number of my other volumes. So these snapshots are stored in Amazon S3. Once I've taken a snapshot, I can use those to easily recreate the database. Let's say I take this one that I took just yesterday. If I want to use a snapshot to make a new database, I can right-click and say Restore from Database Snapshot, and I can then create a brand new database using the material from that snapshot. And I would just fill in this form, and again, it just takes a few minutes to launch the database and get that snapshot in there. So that's just a little bit of detail about the process of doing snapshots and doing backups into S3, but S3 is definitely very, very suitable for storing backups.
Great. Well, thanks, Jeff. That's going to wrap up our webinar on the introduction to Amazon Web Services. On behalf of Amazon Web Services, I'd like to thank you for joining us, and Jeff, again, thank you for the presentation.
You're very welcome. Thank you all for attending.